as well, in which the Greenberg model was given, okay, but we don't have any derivation to get the velocity of the shock wave from the Greenberg model. So we just use this equation to get the parameters which we need for the velocity of the shock wave. The important items were two in all these examples. The first thing is, if the assumption is given that the flow follows green shield model, then you can use the simplified equations which we write for calculating the velocity of the shock wave. Okay, you can use those simplified equations. If it doesn't, then we have the normal generic equation of velocity of the shock wave, which is q1 minus q2 upon k1 minus k2. This applies anywhere. Okay, and then we had some cases in which there was a platoon, and we had some cases in which there was a cube. Okay, so if you have a platoon, then the platoon moves. Okay, so we don't use the velocity, we use relative velocity, relative speed, because the platoon is moving, so then we use relative speed. Okay, and if you have a cube, means the signal closed, the signal opened, or the road is blocked, okay, because of any reason, then you can use the velocity of the shock wave directly. Okay, because there is no velocity of the q is 0. The velocity of the q is 0. Okay, so these are the two important things in these examples. Now moving on, let us talk about gap and gap acceptance. Okay, so this parameter which we are calling as gap, and the acceptance of the gap, it plays a very important role for the interaction of the vehicles when they are entering the highway or leaving the highway, or entering the intersection and leaving the intersection. Okay, so whenever you see vehicles are entering and leaving, merging, diverging, then they do it according to the gap available and the acceptance of the gap. Okay, some of these locations can be a ramp. So from a ramp, vehicles, there are some ramps from where vehicles enter, and there are some ramps from which vehicles exit. Okay, changing of the lanes, again, even when you are going from one lane to the other lane, still gap and gap acceptance is important for you. Okay, so it's everywhere then, right? On intersection, on ramp, and even on the highways between different lanes. Okay, so wherever you are doing this sort of an interaction, entering, exiting, changing the lanes, the most important parameter for you is the gap between the two vehicles. Okay, how much is the gap between the two vehicles where you will enter? Okay, how much is the gap between the two vehicles where you will enter? So if you are trying to enter in the other lane, so there is a vehicle in front of you in that lane and behind you in that lane. You will decide whether I should change my lane or not based upon the gap between them, right? Okay, based upon the gap between them, you will decide. If the gap is small, you will not change the lane. If it is good enough, then you will change the lane, right? Same thing if you are coming from a ramp onto the highway. Okay, so a vehicle has passed you and the next one is coming. You will decide whether I should enter the highway on the basis of the gap between the two vehicles, right? Same thing happens on the roundabouts. Okay, so you are waiting on the roundabout, a vehicle has just passed you, and then you see where is the next one, when will it come, how much time will I have till the next one comes. Okay, so you decide all these decisions on the basis of what? Gap. Okay, so gap is what? The headway between the vehicles of the major stream. Which one is the major stream? Where you are entering. The stream where you are entering becomes the major stream. Okay, so you are coming from the ramp, highway becomes a major stream. If you are changing the lane, the other lane becomes a major stream. Okay, and you yourself, then you are in the minor stream. So gap is the headway which is available in the major stream for the driver of the minor stream. Okay, Now what is the headway? Tell me. Distance? Distance? Time. Usually headway is in terms of time. So gap is usually in terms of time, but it can be in terms of spacing as well. It can be in terms of spacing. Spacing is the distance, okay, between two vehicles. So headway is the time interval between two vehicles and spacing is the distance, but gap is usually in terms of time, headway. Okay, so headway is a normal term, but if you are looking at it from the minor side, then we call it what? Gap. There is a very small difference in the use of the term. Headway is gap and gap is headway, yes. Okay, but we call that headway as the gap if you are looking at it from the minor side. Okay, so there you have headway in your side as well, right? So we call it a headway. Time interval between two vehicles, headway. But if a driver is looking at the headway from the minor side, he is looking to enter it, then we call that headway as, yeah, clear? Clear? Okay. So, but in some cases it can be in terms of distance as well. How much distance you have between two vehicles. But normally it's in terms of time. Okay. Yes. So in this figure, you see this is a stop sign on the road. Okay. This is a stop. So this shows the distance, and this one shows the time. Okay. And these are vehicles. These are different vehicles when they are crossing the stop sign. So you are waiting here. At this distance you are waiting. Okay. So one vehicle passed you and the next one came after this much time. You feel this much time is not enough. So you will keep on waiting, right? The next one has slightly more time. You cannot see it that much, but it has slightly more time. But still you feel it is not safe. Okay. Then slightly more time, still not safe. But now you see the gap is even bigger. Okay. So now you decide I can move now. The first vehicle has passed. The next one is so much behind now. So between these two vehicles, now you decide to move. Okay. This is what we call as gap acceptance. Okay. So you are looking at the headway between two vehicles. Okay. From the minor side, this is, from your point of view, it is gap. Okay. When you find a gap in which you decide I can enter, this is called as gap acceptance. Clear? Clear? Okay. First of all, look at the graph, this graph. Okay. So we have the gap, the value of the gap on the x-axis, and the number of gaps which are available for that value. Like how many vehicles are going at this value. Okay, so for example, value of 1 second. So how many vehicles have a gap of 1 second between them? Okay. Or the number of, yes, sorry. No. How many vehicles or how many gaps of this value are available? Okay. So you see two graphs here, right? Two curves here. Okay. One is for gaps rejected, the other one is for gap accepted. Okay. This graph, which is going down, is for gaps rejected. This one is for gaps accepted. Okay. Now you see, when the value of gap increases, okay, more people will use it or less people will use it? More, right? More people are willing to use that value. Okay. And then there are some math guys as well. Okay. We'll use 0 as well. Let us die together. Anyways. So you see, when the time gap increases, this graph is going down. Why it is going down? Because less people will reject it. Okay. So a gap of 1 second, many people will reject because it's very small. A gap of 5 seconds, very few people will reject it. Got it? Clear? Huh? as the gap increases, number of people who will not go in that will be less. Okay? And the other way around is also true, right? When the gap increases, number of people who will accept it will become what? More. And the gap increases, number of people who will accept it, like who will decide to go in that, will be more. So when the value of gap increases, number of people rejecting it will be less, number of people accepting it will be more. So this graph goes down, this one goes up. Clear? Clear? Okay. So they were measuring the gap and they were recording this value is accepted by how many people and this value is rejected by how many people. Okay. Now it can happen, you can see it in the graph as well. For example, value of 3 seconds. I have some people who think they are very good drivers coming out of Formula 1 will go. Right? Hamza. Okay? That's why he's always late. And the same gap is just rejected by a few people, right? So at every value you will find some people accepting it, some people rejecting it. Okay? So even if you go up to here, 5 seconds, there are some people who have nothing to do in their life. They are enjoying themselves on the intersection. Okay? Why should we go anywhere? Okay? So even at 5 seconds they are not willing to go. My wife. Don't tell him. Okay? And then there are some people who will accept, obviously, many people who will accept it. So at all values, you have the driver's choice here. Okay? So there is no certain value at which, or that value will be very, very high. But for most of the values, you see, there are numbers on both sides. Okay? There are drivers rejecting it and there are drivers accepting it. Clear? There are numbers on both sides. So I cannot, until and unless I make the value very, very high, okay, 6 seconds, 10 seconds, something like this, that value is very high, which is impractical. In normal traffic stream, you may not find that much gap. Okay, so for a normal range of headway, 2, 3, 4 seconds, you will always have people who will accept it and people who will reject it. Okay, so what we try to provide or what we consider as important for us is the critical gap. What is the critical gap? The value of gap or headway which is accepted and rejected by same number of people. Okay, so if you see here, rejection is high, acceptance is low, right? If you see here, rejection is low, acceptance is high. Critical gap is which one? Where both are same. Okay, the intersection point of the rejection and acceptance curve. So we call it as what? Critical gap. Okay. Now if you can get the data and you can plot the graph very accurately, your data is very accurate, okay, like it is accurate at 2, 3, 4 decimal places, then this point, okay, maybe and you plotted the graph using the software, okay, and the software exactly gives you where these curves are meeting, then no problem. Yes, no problem. Okay, but we know collecting especially this data with this is already in seconds. Okay, so if you try to make it more accurate, you have to go up to microseconds or milliseconds. This is very difficult, right? Okay, so if your data is less accurate, that means the graphs are also less accurate and so on. So they have come up with a mathematical approach to find out the critical gap, the value of the critical gap, at which value these graphs will intercept. Okay, but if you can plot the graphs accurately, you have the data, accurate data, then you can, it's simply the intersection point. Okay, so how do we find the value of the critical gap using the graphs? The critical gap is represented as TC. What is TC? The critical gap, the value which we are looking for, where both curves are meeting 50% of the drivers are accepting it, 50% are rejecting it. Okay, so this is the value we want. There is a value before this, any value of gap before TC, we call it T1. Okay, so T1 is before TC, and there is a value which is T2, which is after TC. So TC is between T1 and T2. Okay, so there is a value before the intersection point, we are calling it T1. There is a value after intersection point, we are calling it T2. Clear? For each value, so for example, if you take T1, okay, if you take T1, so at T1, I have a value on the acceptance graph on the y-axis, and I have a value on the rejection graph on the for the y-axis. T1 has two values, right? One for each curve. So the y value of T1 on the acceptance graph is m. The y value for T1. So if you are at T1, you go to the acceptance curve, the y value is m. Okay, and if you go to the rejection curve at the same T1, the value at the rejection curve is r. Okay, so if you draw a line from T1 to both curves, you will get r and m. The lower value is m, the upper value is r. Clear? Same thing for T2 as well. You draw a line from T2, you will get a value on the acceptance curve, on the rejection curve and the acceptance curve. Okay? The value on the rejection curve is P, the value on the acceptance curve is N. Okay? So lower value is P, upper value is N. Clear?
T1 and T2 randomly drawn.
Yes, random. But there should be one should be before intersection, one after. Okay? Okay? Now, you see here this slope and this slope. Okay, they are continuing, right? Okay. So, I think I'm getting wrong. Let me check. Okay. You see, this is for T1. This is a small triangle. Okay, this is one triangle. Okay, and then you see this is another triangle. This one, small one, and this, the big one. Okay, clear? We have a small triangle here, and we have the big triangle here. Okay, now the difference between T1 and T2, the difference between T1 and T2 is delta T. The difference between T1 and T2 is what? Delta. The difference between T1 and TC, what is TC? Critical gap. The difference between T1 and critical gap is delta T1. It is what? Delta T1. Got it? Okay. Now look at this triangle, the small one. Okay? Look at the small triangle. What is the base of this triangle? Delta T1. Okay? The difference between T1 and TC. The base is how much? Delta T. Okay? And what is the height of this triangle? Okay, the base is delta T1 and the height is R minus. Okay, what about this triangle? What is the, okay, let me start the easier one. What is the height of this triangle? n minus 1. Okay, height is n minus 1. What is the base of this triangle? Yeah, delta t, which is from t1 to t2 minus delta t. Okay. Okay, and because the slopes are equal, these two triangles are similar triangles. Got it? Okay. So base upon height for this small one, and base upon base upon height for the big one. Okay, and both of them are equal because the slopes are same, so triangles are similar triangles. Clear? Clear up till here? Okay, any problem? Okay. Now in this equation I have delta T1, right? Okay, and delta T1 equals to what? T1? Huh? No, delta T1. Difference between T1 and TC. Delta T1 is the difference between T1 and TC. Delta T is between T1. Clear? Okay. So I have delta T1 here. I can replace delta T1 with TC minus T1. Okay. Delta T1 will be replaced with TC minus T1. Okay. I'm trying to get what? Critical gap. Okay. So I replace delta T1 with TC minus TC minus T1. Okay, and then I will rearrange the equation for TC. This is the equation for TC. TC is what? Critical gap. What is critical gap? Yeah. 50-50 what? 50 accept, 50 reject. We have a biscuit in Pakistan. 50-50. Okay.
What is the other triangle?
Which triangle?
Bigger one and small.
This is a smaller one between TC and T1. Okay. Clear? Any other question? So this is the equation we have for finding out the critical gap. Here you don't need the graph. You don't need to plot the graph and find out the exact intersection point. Okay, you just need these values R, M, and so on. Okay, so for example, if I have this table, okay, so in this table I have the values of gaps. Okay, for each value I have number of gaps accepted, which is this line, the value for this line, and I have the number of gaps rejected, which is the value for this line. Okay, so I don't need to plot them now. I don't need to plot anything. Okay, I will select two values as T1 and T2. Okay, so you can see here they have selected 3 and 4. Okay, so my T1 is 3 seconds, T2 is 4 seconds. Okay, so at T1, the value on the acceptance curve is termed here as M. Okay, and the value on the other curve is R at T1. Okay, so this is M and R, and at T2 the acceptance curve value is N and the rejection curve value is P. Okay, so if these are the values given, then what is the value of TC here? Okay. Now we picked here 3 and 4 seconds, right? 3 seconds and 4 seconds. T1 was 3 seconds, T2 is 4 seconds. Can I put 1 and 2 here? T1 1 second, T2 2 seconds. Can I do this? Why not?
There is no intersection.
There's no how do I know that there's an intersection? How do I know the intersection is between 3 and 4? Forget about the graph. The graph is not plotted. That's all. This is why we came up with the equation, right? So we don't have to plot the graph. So how do I know from the table that which one should be T1, which one should be T2? What tells me? You check what? Say again? Yeah. Say again? Yeah, yeah. T1 is before critical. T1 is before critical, right? So before critical, rejection is more, acceptance is less. See here. Acceptance is less, rejection is more. Okay, T1. And T2 is after critical. T2 is after critical. So acceptance is more, rejection is less. Got it? So rejection is less, acceptance is more. So you see it's flipped. Between 3 and 4 seconds, it is flipped now. At 3 seconds, this was more than this. At 3 seconds, rejection is more than acceptance. At 4 seconds, acceptance is more than rejection. So this tells you the intersection is between them. Okay? So this will not work if you took 5 and 6. Okay? It works when T1 is before TC and T2 is after. Okay? So here you see rejection is more. 0, 116, rejection is more. Rejection is more. Rejection is more. Rejection is more. Then after this, rejection is this. So this tells you between these two values there is the critical one. Got it? Okay? So first thing is we have to pick which values should I take, which values have the critical between them. Okay? So you will see where the table is flipping. Okay? Initially the rejection will be more, where the acceptance is becoming higher. You will pick those two values. Okay? Clear?
So can you repeat last point? How we can between
See, if you take at 0, rejection is more, right? More than acceptance. Here, more. Here, more. Here, more. Here, yes. So where it goes from more to less, this is your T1 and T2. Clear? Clear? Got it? Ibrahim. Everybody is trying to explain to Ibrahim.
No. He explained to us.
Huh? But you were talking.
I was asking.
Very good. Okay. Okay, let's say on a highway, the traffic flow is 360 vehicles per hour. Okay, the highway has a flow of 360 vehicles per hour. If this is the flow in 1 hour, how many vehicles can I have in 5 minutes? Tell me. Number of vehicles in 5 minutes. 360 in 1 hour, how many in 5 minutes? How many? 90? 90? 30. 5, not 15. Okay? Very easy, right? Okay. If 360 vehicles are coming in 1 hour, how much is the time interval between them? Tell me. Headway. If you have 360 vehicles in 1 hour, then how many seconds between each two vehicles? Tell me. 0.11 hours? Maybe. Huh? 10 seconds? I don't know. 10 seconds. Yeah, 10 seconds. Yeah.
What about that?
Huh? 10 seconds. 360 in 1 hour, right? And the hour has 3,600 seconds. So 3,600 divided by 360. 10 seconds. Huh?
0.1.
0.1 what?
0.1 hour.
0.1 hour. 0.1 hour is how much?
1 less.
6 seconds. An hour has 100 minutes.
No.
Okay, clear. Okay, we have seen this equation previously as well. One of the previous slides had this equation. Okay, so but what did we do here? In both these cases, what did we do? We said after every 10 seconds there's a vehicle, right? Total flow is 360. So that means after every 10 seconds there's a vehicle, and if I observe for 5 minutes, I will get 30 vehicles. If I observe for another 5 minutes, 60. Another 5 minutes, 90. Okay? What are we assuming? Same flow. The interval between the vehicles is always the same. Okay? The interval between the first two vehicles is 10 seconds, next two vehicles 10 seconds. It doesn't change. This is what we call as uniform arrival of vehicles or deterministic arrival of vehicles. Uniform because you are assuming same gap, right? So it's uniform. The gap is constant, uniform. Okay. Deterministic means a value which has no other variation. Okay. A value about which you are 100% certain. I will just get this value. There is no other possible value. So we call it deterministic arrival. Okay, or a deterministic value. Okay, uniform means it's constant. We call it uniform because you are assuming a constant value of the interval, constant value of the flow, and so on.
Can be in the real,
Huh?
can be in the real, uniform flow.
It can be?
The what? The real.
No, it's not. It's not. Okay, but what we have done up till now, from traffic engineering to now, up till now, what we have done this. This is the flow, this much in 5 minutes, this much in 15 minutes, this much in half an hour, and so on. This is what we did, right? Up till now, we have not talked about there could be any other value. Okay? So actually what happens? The 5 minutes could have 30, right? Could have 30. But can it have 31 vehicles? Any 5 minute interval in this 1 hour, can it have 31 vehicles? Can it have less than 30 vehicles? Right? This is possible, right? So there is a chance that instead of 30, I may have some other value. There is a chance that the headway between any two vehicles could be less than 10 or more than 10. Okay? So the assumption which we make that my flow is deterministic, there is only one value. Okay? It's not true. It's not valid. Okay? It's not valid. This value has a chance. This value which you are giving me, 30 and 10, these values have a chance. But there is a chance of having other values as well, right? Okay? So the real flow follows what we call as stochastic arrival. The real traffic flow is not deterministic, it is stochastic. Okay? So deterministic means single value, 100% chance of this value, deterministic. Okay? But the real is different values having their different chances. This is called as stochastic. Okay, clear? When you go for a stochastic approach and start considering the chances now, instead of just one value with 100% certainty, now we are saying, okay, value of 1 has a chance, value of 2 has a chance, value of 3 has a chance. This is a stochastic approach. Okay. Now we are interested in finding out what is the chance that I can have a value of 10 seconds. What is the chance? I know 10 seconds can happen. Yes, it can happen. But the 12 seconds can also happen, right? So what is the chance that I can have 10 seconds of gap or headway? And what is the chance I can have 12 seconds? So I'm not interested in finding out the value. I'm interested in finding out its chance, probability, chance. Okay? What is the probability of this value? What is the probability of this value? So when you go for a stochastic approach, the important thing for you is not the value. It's the probability of the value, the chance of the value. Okay? We will take that value that has higher chance, higher probability. Got it? Clear? Okay. In traffic engineering, we talked about a distribution. Anybody remembers? Normal distribution. Okay? So there was a graph, there was a table, Z table. Okay? And we are taking probabilities from the table. Okay? So, similarly, when it comes to traffic flow, we have another distribution. The name is very good, actually. If you say it the way it should be said. Poison, right? Okay. It's like a poison.
Like the exam.
Huh? No, even the class is poison. Okay? Exam was okay. 2 hours you go.
The whole
That-
course is a poison.
The results are not okay. Okay. Anyways, I had a friend, teacher, whatever you call it. He was very smart. He didn't used to call it poison. Poison. He will call it poison. Okay.
That's bigger than poison.
Hmm?
More dangerous.
I'll ask him to come and teach here as well. He was just now in Saudi. Anyways. So, like we have normal distribution, we have Poisson distribution as well. Okay. So somebody told us that if you want to perform this test, you should use normal distribution, because they already did the research and they found for those tests normal distribution is good. Using z values is good. So again, to our convenience, somebody did the research on traffic flow and they found that to calculate the probabilities for traffic flow, you don't use normal distribution, use Poisson distribution. Okay? This is the graph for Poisson distribution. Okay? Can you remember the shape of the normal distribution? Huh? Anybody can do this. A bell shape. Okay? It was symmetric, right? Symmetric bell shape. This one is slightly skewed. Okay? And based upon the numbers of the distribution, the skewness can be on this side or this side. You can see this one. This is also Poisson. You can see it. There is no end. Okay? So, but the difference between Poisson and normal is symmetric, Poisson is like the name. Okay? To calculate the probability of a value according to Poisson distribution, by the way, if you go to the normal distribution and look at the P equation for normal distribution, it is much more scary. Like it is this big, and it has square root and exponential, everything in it. Okay, so this one is easier, relatively easier, believe me. Okay, so I am trying to calculate the chance that my flow has a value of x. X is my value. X is the value for which I am calculating the chance. What do I need? I need mu, I need mu again, and I need x and mu. Okay? Clear? Somebody may say we need E as well. We don't need E. Okay, E for elephant, we know that, right? Huh?
Calculate.
Okay. That is C. Anyways, so what is mu here? Mu is average number of vehicles arriving in time t. So you have an observation time. I'm finding out in words what is the probability of having x vehicles in how much time? Okay. And mu is the average of x. Got it? Mu is the average of x. So if I give you 100 values, can you calculate an average?
Yes,
Yeah.
You can, right?
you can.
Huh? He is more confident than you. He doesn't even have a calculator.
Engineer.
Huh?
Civil engineer.
Not yet. Okay. So you calculate the average, right? Average is mu. If you have 1000 different values of x, you calculate the average is mu. Out of these values, out of those 1000 values, now I pick a value, let's say 5. I pick a value 5. So 5 will be what? X. So what is the chance that my flow is 5? The average could be 10, 20, 30, whatever. That will be mu. Okay. Now how do I get the value of mu? There is an equation for it. Normally we take the flow per hour, right? Per hour, per day, something like this. Okay. T is usually smaller, and we will discuss it later on. Small t is usually very small. So if you want the value of, we can replace mu with lambda into t. What is lambda? Rate of arrival of vehicles, average rate of arrival of vehicles. Okay, in your entire time period. Okay, and then you multiply this lambda with a small t, it becomes the average number of vehicles in time small t. Okay, let me explain what we are doing. You have taken data for the entire day. For the entire day, your capital T is how much? The day. The day. Okay. And V is the value you have in the day. Clear? Clear? Okay. Now, from the entire day, I want to find out what is the chance that in 15 minutes I will have 10 cars. So what is my small t? 15 minutes. Got it? Clear? Okay. Now how do I get lambda? You have the value for the entire day. That value is V. V. What is T? Capital T? The day. Okay. In that day you picked a small observation time, that is small t. Whatever. 15 minutes, 20 minutes, whatever. Okay. So you have the full time period for which V is available. And from that time period, now you pick a small gap, a small interval, that is your small t. Got it? Clear? Okay. So in this equation there was mu. Mu can be replaced by lambda into small t. What is your lambda? This ratio. What is your small t? Huh? The small time interval for which you are finding out the x. Clear? Okay. So replace mu with lambda into t in this equation. Mu equals lambda into t. Okay. So wherever there was mu, I replace with lambda into t. So the final equation is this one. Clear? Okay. Now, one small thing here. Let's say the headway between the vehicles is 3 seconds. The headway between the vehicles is 3 seconds. And your small t is 1 second. Your small t is how much? 1 second. So how many vehicles you can see in 1 second passing? The headway is 3 seconds. And you are only doing observation for 1 second. So how many vehicles you will see?
One, only first one. First one.
0. First one already passed, right?
Yeah, only first.
Yeah. So 0, right?
Yeah.
So if my headway is more than my observation time, then x is how much? So if I put x here as 0, so this will become 1, right? And this will also become 1. So the final equation is what? E to the power this. This is 1, this is 1. Got it? Okay. So if I put x equals to 0, x equals to 0 means what? My observation time is less than the headway. My observation time is less than the headway. Okay. This one. Then x equals to 0, equation simple. Okay. Now if I say, so this is chance, right? Probability. Probability. If I say probability of 0 is 10%. Probability of 0 is 10%. Then probability of not 0 is how much? 90%. Okay. So 1 minus. 1 minus. Okay. Now remember, x was 0 when headway was more than 10. Okay. So this is the probability when headway is less. Clear? Clear? Any questions? What? Yeah. And obviously, as a check, if you do this and this, you add them together, you should get. Okay. Clear? Any questions? Okay. So next time we will do some examples for the same.